Okay, good evening and Assalamualaikum. This is class number 7 actually. Okay, today we will continue with the topic that we had last week. We will cover the topic on, if I'm not mistaken, topic 6 that we have done last week. We complete the topic 6 and we'll move on to the topic 7. Topic 6 will be on the continue with the little bit on the just quick run through on the branch probably on the computing the branch probabilities using Bayes theorem. Just go through quickly, and then because today will be the last class where we have lecture. Next week will be your uh, presentation. No, not next week. The other week at 20. When is your presentation date? Your presentation date will be on the 21st. 21st will be your presentation date, and that will be the last class. And then I will do a quick run through after the presentation. So today is actually the last class. So the notes for this topic is already in your LMS. Today we'll cover a little bit on we'll run through on computing branch probabilities using Bayes theorem. And then we move into utility theory. Then we do the decision making analytics using when the situation is of uncertainty. We'll deploy the Monte Carlo simulation. After that, that will be in topic 6. After we done topic 6, we'll move straight away to topic 7. Topic 7, we'll do how do we do the system development for intelligent system, the BI, the traditional approach, and the BI application releases. And then I'll go through about on data warehousing, data mart, ETL, and so on. Yeah. So hopefully we'll be able to complete this during this 1.5 hour. Okay, I will just go through quickly. Okay, we'll start with okay. I'll share my screen. This is where we left last week, computing branch probabilities using with Bayes theorem. Okay, when similarly we had decision analysis using this is prescriptive analytics. Prescriptive analytics, there are 3 situations where we have complete knowledge, and then where we have probabilistic condition, where there is risk, and then we have the last is uncertainty, when there is we don't have knowledge. So we have gone through in the beginning, we have gone through the problem formulation. We will start last week. We talked about problem formulation, and then we look into the chance events and outcomes. The case that we use is on this three decision that we need to make, whether we want to develop 30 condominiums, 60 condominiums, or 90 condominiums. And then with the information knowledge, with some knowledge of this, with sufficient knowledge, we calculate the payoff, and we develop payoff tables. And then we will be able to develop a decision tree. From this decision tree, we will be able to calculate which decision that we want to make based on the payoff. And then we move on to decision analysis this is without probabilities, an optimistic approach, and then a conservative approach. So we chose during optimistic approach, we chose the 20 large complex because we provide 20 million return. And then during the conservative approach, at conservative approach, we pick up the small complex because it provides the maximum of minimum payoff of 7 million. Okay, and then we have also covered the minimax regret. There is a formula there. And then decision analysis with probabilities. We are not looking at the payoff. We are looking at the expected value. So how do we calculate the expected value? We include it with it the weighted probability. So PSJ there is the weighted probability. We will multiply with the with the payoff, and then we'll get the expected value. So this is the situation. And then we'll also move into the sensitivity analysis where we are able to change the situation between the probabilities of the probabilities. And then in this situation where instead of the earlier we have 0.8 chances of strong demand, now we have 0.8 chances of weak demand. So we can see the assessment be different, and then the expected value is more towards the smaller condominium, where it can generate about 7.2 million. And now we have also moved into decision analysis with sampling, where we have done sampling, and then in the sampling we have favorable report and unfavorable report. Next, we will move into the conditional. So when we have sampling and we have favorable report or unfavorable report, so we can have this situation where there is a conditional probability based on the favorable market report. So subject to favorable market report, and then we will calculate the probability subject to the favorable market report. So we apply Bayes' theorem, which is based on a conditional probability. So this is the how do you compute conditional branch probability with the Bayes' theorem, where there are situations where we have market study and non-market study, and then with favorable report, we have the chances for the favorable report, and then a unfavorable report. So we have probability for the unfavorable report. So in performing the probability computations, we need to know the assessment of the probability of the two states of nature, whether it is strong demand or weak demand, and then condition on the favorable report or non-favorable report. So unfavorable report. So we apply the Bayes' theorem. This is the formula of Bayes' theorem, where it is subject to the condition of a favorable report or an unfavorable report, and then you are able to determine the expected value. Okay, that is the Bayes' theorem. Now we move into utility theory. As we know that not all situations are totally based on monetary value. Sometimes we make decision on the condition of environment, condition of say society, effect to the society, and the condition of governance. So we can put a monetary value into the expected value. So we use an expected utility to identify the desirable decision alternative, and then instead of putting monetary value, we replace it with a utility value so that we can commensurate how will we make decision. Okay, in this situation, in this case, it is based on risk. So there can be the cash requirement based on the risk. So there is three decision alternative, whether to invest in A, invest in B, or do not invest at all. And then the states of nature is whether the price will go up, or price will stable, or price will go down. And then this is the state of nature payoff table based on the monetary value. But there is a situation now, we look into the risk avoider. We want to have to avoid risk, meaning that the best payoff will have larger utility than a worse payoff. So we will develop a payoff table using some kind of monetary value to make sure that, and then we develop the probability of best payoff and probability of worst payoff. So same way like we did the expected utility, but we replace the value with the non-monetary value, which is the risk. So you can also apply this equation not just on risk, but you can also apply in other aspects of uh, non-monetary, like like environment, society, or the governance, for example. So in this case, it is utility function. Okay, I've given the notes with you, so you just go through the notes, looking into the situation of risk avoider, risk neutral, and risk taker. Okay, this is situation of exponential utility. Okay, now we move into the third situation where uh, we had two situations. One is where we have certainty, we have discussed last week, and then we have also discussed last week on the situation of probabilistic, meaning that risk. We calculate based on risk, and then we have probability of the risk, and then instead of we make decision based on payoff, we make this decision based on the expected value. Now, the third situation is where we don't have any information. So where there is uncertainty. So most situation we have this uncertainty for decision making. We do not have enough information to make decision. So we apply what we call Monte Carlo simulation. Monte Carlo simulation is used to evaluate impact of uncertainty on a decision. What would be the impact? So it's being applied by generating random numbers. So you apply random numbers based on the model, the financial model that you have. We talked about financial model earlier. I think in the beginning of this course we have been talking about financial model or the mathematical model. And then based on the mathematical model that we have, we generate random numbers. So these simulation models have been successful in financial applications like financial planning, project selection, option pricing. Is also applicable in marketing applications, new product development, time to enter the new market, and then like also in project management, inventory ordering, and so on. So uh, the probability distribution is which is not about just the range of possible values, but also relative likelihood of certain outcome, yeah, of various outcome in the situation. So we generate. So when we will generate a simulation model. So when you know that when you generate a simulation model, it will be a what if situation. So we will put a what if situation. We will change the decision variables. When you change the decision variables, what will be the output and the result variables? So it is a what if situation. So and then we will replace the we'll apply the spreadsheet model, replacing the value into the parameters, and then with the probability distribution of possible values. Okay. So parameters that we don't know will be called uncertain variables, and then we will generate random numbers towards these uncertain variables or unknown variables. So we will generate values, random values. So then we can generate simulation. And then we make the decision based on some controllable input, that not on the uncontrollable input, which is the decision variable. So how do we do that? We have a case here, example case, we use this Synotronics from a book, this analysis for Synotronics. This company provide an equipment, a medical equipment for medical device for use in hospital clinics. So they have developed a prototype for a new device that will limit the healthcare workers' exposure to chemotherapy treatments. So while they are preparing, administering, and disposing these hazardous medications. So the company would like to have analysis of the first year potential for the device. So management is concerned on the potential for a loss due to their tight cash flow situation. So as it is the first year, so they have a prototype. This is the first year, and then they have no track record. But there are certain information that they can obtain with regard to this prototype, with regard to this product. So the decision maker want to do a risk analysis. There are certain information that they have. They can develop a model for the first year profit for the medical device. So the company has determined that they will have a selling price per unit at $249. And then they have estimated the first year admin and advertising cost of about 1 million. And then they could see that the direct labor cost per unit, yeah, uh, is will range about between $43 to $47. And then there is parts cost per unit, which range between $80 to $100. And then there is a demand because they don't have any information yet, but the company will be able to produce up to 30,000 units per year. So the demand can be either they don't sell anything, which is zero, to the maximum that they can produce a year of 30,000 units. So these are the basic key parameters that they have. So in situation like this, you will have to gather whatever information that you have, whatever numbers, parameters that you have. In this case, they have this selling price per unit, they have the estimated admin and advertising cost, they know how much will be the direct labor they will spend for per unit, and then what would be the cost per unit, and then they can estimate the first year demand, which will range between not selling at all, zero, to selling the maximum number of production that can produce in a year, so 30,000 units. So they will put this figure, and then yeah, so and then they will work out a base estimate. And from the base estimate, so they know certain at a certain level of certainty that the price they will sell it at $249 per unit. And then the admin and advertising cost will be 1 million. And then they set up some base values, base estimates. Their base estimates with us, the labor cost will be between 43 to 47. The base estimates in the middle, which is 45 per unit, 45 direct labor cost per unit. And then for the part cost, it will range between 80 to 900. So they put in the middle at $90 per unit. And then first year demand, they put in the middle between 15,000, about 15,000 per first year demand. So they will replace this into the standard uh, profit formula. Profit is determined by the contribution margin per unit. What is contribution margin per unit? Is the number that each unit will contribute towards the gross profit of the company, of the product. And so the profit will be calculated by profit minus the cost of labor minus the cost of material, direct material. So P is minus CI minus CP. So where the P is the price, selling price, minus the CI. CI is the cost of labor per unit, and then CP, which is the cost of the parts per unit, material per unit. So P minus CI plus minus CP will get the contribution per unit, and then you multiply by the demand, the number of units that you be sold, you will have a gross profit, and then you minus the cost of for advertisement and admin, which will be the amount of overhead that you incur. You will get some profit before tax, EBITDA, earnings profit before tax. So this is how they calculate the first year profit. So we put the numbers. So we have profit is equals to 249 number, and then minus the CI minus CP times T times 15, 1 million. That is the basic value that we have. And then in order to calculate the base case scenario, you put the number we replace the number, yeah, substituting the value into the formula, we will get $249 minus 45, which is the base as labor cost, minus 90, which is the base material cost, part cost, and then multiply by that is 249 minus 45 minus 90, this is your contribution from the contribution margin multiplied by the number of units, which is 15,000, your base number. And then you minus off uh, the estimate overhead, which is the advertisement cost, admin advertisement cost. You will get a profit of 710,000. So this base case scenario will provide an anticipated profit of 710,000. Okay, that is base case scenario. Now we move into the calculation of we applying what if analysis. You will work out to obtain the worst case scenario and the best case scenario. Worst case scenario, which is the worst situation, and the best case scenario, which is the best situation. So we will replace the number. As we know that from the range just now, from the range, the part cost will be from 80 to 100, and then the direct labor cost is from 45 to 47, and then first year demand range from 0 to 330,000 units. So when you calculate the worst case scenario, what would be the worst case situation? The price will still 249. The first year admin and advertisement cost will still be at 1 million, but the direct labor cost will be the highest, which is 47. The part cost will be the highest, which is 100. And then the first year demand will be the lowest, which is 0. So we replace that value to obtain the worst case scenario. Worst case scenario, we obtain the direct labor cost will be 47, the highest value, part cost 100, highest value, and the demand, the lowest value will be 0. Substituting this value will make a loss of 1 million. 249 minus 47 minus 100, but you multiply by 0 unit of cost, 0 unit of demand, 0 unit of sales. So it will be 0, and then minus of the cost of advertisement and admin advertisement, you'll get minus of 1 million. So worst case scenario will lead to a projected loss of 1 million. Okay, and then we work out the best case scenario. Working the best case scenario, we'll have, so when you look into this range just now, the best case scenario will be the lowest labor cost, the lowest part cost, and the highest demand. The highest demand is 30,000. Yeah, so the best case scenario is where we have the direct labor cost is 43, the parts cost is 80, and the demand is 30,000, highest value. So we substitute the value, we will get a profit of 2.78 million. Yeah, so the best case scenario leads to a projected profit of 2.78 million. Just put, and then this formula you need to know in maybe assessment. Some formula you need to know, like break even number. How do you calculate break even number, which is the situation where there is no profit, no loss. So where the contribution margin minus multiply by the demand will it be equal uh, the fixed cost, yeah, will equals the fixed cost. So uh, the number of units, the number of demand will be the situation where the contribution margin minus fixed cost will be 0. So okay, that some basic numbers you need to know for your assessment. Some basic numbers, basic formulas, basic. Then, so this best case scenario, using this what if analysis, you can see that there is they can be between may range from a lot. So the profit can range from a loss of 1 million to a profit of 2.78 million with a base profit of 710,000. So this is a simple what if analysis that we can do. And then you replace that formula developing a spreadsheet model. So I provide here the spreadsheet model example. I will upload this in your this electronic file in your LMS. Then you need to calculate in order to do the risk analysis, you can use probability distribution to represent random variables. So you will generate, Monte Carlo simulation is about randomly generating random values for the random variables. So the random variables will be things that has not been determined yet, which is the direct labor, which can range from 43 to 47. You will generate a random number range between 43 to 47. And then part cost will range between 70 to 100, yeah, just now, 70 to 100, the direct labor. So we'll generate the random number for that, 80 to 100, yeah, part cost, and then the demand will range between 0 to 30,000. So you will generate the random number to calculate, do a probability distribution to represent some random variables. So for this for the direct labor, it range between 43 to 47. So from this 43, we do a discrete probability distribution from 43 to 47. So discrete probability distribution is calculated using this model. So the probability to having 43 is 0.1. So the interval number will be 0.0 to 0.1. 44 is 0.2. Yeah, so it will be, because 44 is yes, 0.2, it will be 0.1 to 0.3. 45 is 0.4, 0.3 point 0.7. So we will generate the random number. This is the middle that you have, generating the random number. Senetronic believes that the direct labor cost will range from 43, and then it's described 43 to 47 and described by the discrete probability distribution. There could be two types of probability distribution. It can be continuous probability distribution as well as discrete probability distribution. So in this case, the company believes that the direct labor cost will be in a discrete probability distribution. So they will generate the probability distribution, discrete probability distribution as this, yeah, from 43 to 47. Yeah. And then in the part cost, they believe that it will be a continuous probability distribution. So with a uniform probability distribution, so it will be 1 over 20, because 80 to 100 is 20. So the chances of any value here will be 1 over 20. And then it is a continuous property. And then based on the normal distribution for the first year demand, so the average is or the mean is 15,000, and then the variance is 4,500. So based on variance 4,500, they will generate a random number. Yeah. How do you generate a random number based on this? Okay. We start with the labor cost first. Labor cost, how do you calculate? You take a lower bound, and then you take the upper bound. Lower bound is 43. Upper bound, which is 47 minus the lower bound 43, and then you multiply with the random number. Okay, random number will get, when you put in the random number Excel, you just type in RAND bracket in Excel, it will generate a number from 0 to 1. Yeah, 0 to 1. So the random number will generate between 0 to 1. And then you multiply by the random number, it will provide you that number. Yeah, this is in the this is for parts cost. Yeah, and same goes for the same thing will go for the labor cost. Yeah. same thing will be generated for the labor cost. For example, if the random number is generated from 0 to 1, say it is 0.9109, so it will be between 0 and 9, so it will be within the $47. If it is between 0.81, so it will be within the $44 per unit. So it will generate the random numbers. And then for the demand, this is for part cost. For the demand, you will apply the normal inverse using the mean and the variance. Mean is 15,000, the variance is 4,500. And then it will generate a random number here. Any portion within this random number. Then you put them into Excel model. This is the Excel model. I'll put up this Excel model in your LMS first. You can play with it. And then you can try to generate random numbers. And then using Excel, you can generate 1,000 times or 10,000 times or 100 times random number. So in this case, this case uses 1,000 times what if analysis. So we'll generate a simulation of 1,000 times. From the 1,000 times, it will generate these numbers, and then you can see the probability distribution, profit distribution based on probability. You will be able to work out the minimum profit summary statistic. The count is 1,000, minimum loss, maximum profit, the mean, standard deviation based on the simulation, random simulation, based on the random simulation. Okay, that is for topic 6. Topic 6 is the last case is on a random simulation using random number, you generate random number. This is Monte Carlo simulation. Okay, I'll continue with topic 7. Yeah, this is the last topic. Topic 7, there are a number of slides. The notes are already with you, and then you can go back and go through the notes. Let me share the topic 7. Topic 7 only have about 40 slides. Okay. Okay, this is the last topic for this course. Yeah? The last topic, actually, there are 10 topics, but we have 7 classes. So I, I combined some of them so that we only have 7 topics, just each topic for each class. So for any system development, this is the development approach. So first stage, you need to, any business system suitable for businesses, you need to have some justification. You need to develop some CVP analysis. CVP analysis is cost, volume, profit analysis. And then you need to determine the cost benefit analysis. What it will be the cost and what will be the benefit of developing such cost, and then what would be the need to developing any system. So the same goes with the business intelligence. You need to have some justification, and then you will start doing the planning, and then you do the business analysis because it's meant for business systems. So you need to do some business analysis, start design, constructing, and deployment. So the traditional development approach, this is what we call earlier we termed this as SDLC, System Software Development Life Cycle. Those in IT will not familiar with this SDLC, or we call it waterfall approach. The waterfall approach will start with the business need. You need to have a business need before you should embark into any system development, software development. You will do your project planning, and then you will have your functional requirement. Of course, it's not just functional requirement. The main thing is just the functional requirement. But besides functional requirement, you can also have some non-functional requirement. the difference between functional requirements and non-functional requirements is the functional requirements enable the system to deliver its main function, where the non-functional requirement is the added value. For example, like a functional requirement of a car is to be able to allow you to travel from point A to one point B. As long as you can travel from point A to point B, it meets the functional requirements. But not you are not looking just at the functional requirement. You can also look into the non-functional requirement, which is the other values that you can add on, like speed, the comfort, and so on. So, but the traditional approach looking more into the functional requirements. From this functional requirement, we'll develop system analysis, and then what will be we do analysis of the system, what will the system needs, and then we'll design the system and then start developing, testing. There will be several level of testing, unit testing, and so on, and then implement and then maintenance. So this is a waterfall approach. But for business intelligence application, there will be iterative releases. So we'll start with business opportunity. So usually this business opportunity will come from the opportunity of enhancing your businesses, or you look into problems. What are the problems that you can use PI to improvise your decision making, business decision making? And then you look into your decision support strategy. How does the company make decisions? Are they data driven? So with this decision support strategy, and then we'll develop the strategic planning. In doing in the project planning, they will look into strategic information requirements that the company apply uses to make their decision. Yeah, what is the strategic information requirements for making the decisions, and then do business analysis. Business analysis, you will look into your business processes. What are the business processes? Break into your business processes, and then at business processor will be categorized into three levels, which is the operational level, the tactical or functional level, and also the top strategic level. So you do the business analysis. After and then you will start doing the design based on the analysis that you have done. And then from the design, you will develop testing unit analysis, unit testing, integrated testing, and then implement, and then you will do a release. And then from time to time, you will evaluate your release and then continue with another business opportunity. So it is an iterative cycle, continuously to improve your BI application release. So in most of the time, there will be cross-organizational development approach where you, from the justification, you will do a business case assessment from several units, and then you look into your enterprise infrastructure evaluation. Then only you'll do your project planning. Then you have a business analysis here. Business analysis will look into the project requirement definition. What you define your project requirement, functional and non-functional. We'll do your what sort of data do you have, what kind of analysis that we use in processing the data, and then you will develop your application prototyping, and then in making decision, you will not only look into the main data, we also look into the metadata repository. So you have a metadata repository, you will develop your database design, you have a metadata repository design, and then how do you do your ETL, extract, transform, and load? We will discuss later in detail what is a ETL, extract, transform, load design, and then you will do your ETL development, extract, transform, and load. How you collect your data, how do you extract your data, you transform your data, and you load data into your data repository or your data warehouse or data mart. And then same goes with database design. You will do your application development. You will do your data mining. What we have covered data mining earlier. So you'll do your constructing your data mining design, and then also your metadata repository development. Then you implement. Then you'll do your release evaluation. It will be iterative. Yeah, it will be iterative. So like we covered earlier, so the basic thing in when you talk about business intelligence will be data warehousing. So data warehousing is where all this data will be gathered, collected. So you could do your descriptive analytics, predictive analytics, and prescriptive analytics. So the BI part is the descriptive analytics part, and then the business analytics part is in the advanced analytics, which is the predictive analytics and prescriptive analytics, which we have covered. Yeah. So what is data warehouse? Data warehouse is actually a physical repository where currently we do relational data, but beside data warehouse, we can also have a non-relational database that we can come through our big data. So data warehouse is a physical repository where you have relational data organized so that you can provide enterprise-wide clean data in the standard format so that you can do data mining, you can do your analysis, you can do your descriptive, predictive, and prescriptive analysis. So data warehouse is a collection of integrated, subject-oriented. You organize it based on or uh, uh, subject-oriented database designed to support a DSS, decision support system function, where each unit of data is non-volatile. Non-volatile means you cannot change your data. I mean, when it comes in, it will stick there. And then if you want to make some changes, you will need to post another entry to make the changes, to make to effect the changes, not to make the changes, to effect the changes. For example, like those in the accounting background will know that if you have accidentally or erroneously debited an account, you have to credit an account. So you have to do another entry to reverse the amount. That is what it means by non-volatile, meaning that you cannot change the data, but you can input another data to have an effect that uh, re, uh, that reverse the value. Yeah. And then this database will be relevant. The data warehouse will be relevant to some moment in time. The database in the data warehouse will be relevant to some moment in time. So develop the basic history of this database of this data warehouse originated when we earlier we have these mainframe computers. We have simple data entry. We move into reporting, routine reporting. We have primitive database structure. And then in 1980, we have this mini personal computer. We have many business applications for the PC. We have distributed database management system. And then we have relational database management system. And then they coined the term business data warehouse. Then I move into centralized data storage. We have data warehousing, and then there is two methods of developing data warehouse, which is the Inman method and the Kimball method. We'll discuss later what is the Inman method and the Kimball method in developing data warehouse. Then we have this enterprise data warehouse architecture. Yeah, we'll also discuss later on the enterprise data warehouse architecture. So in year 2000, with the web data, we have exponentially grow the web data. Then we consolidate the data warehouse with the business intelligence industry. Data warehouse appliances have emerged. And then being popularized the business intelligence. And then we have data mining and predictive modeling. And then there is some open source software. We have software as a service, platform as a service. We have cloud computing. In year 2010, we have this big data analytics. We have social media analytics, text and web analytics, Hadoop, which is under the Apache Foundation, MapReduce, NoSQL, not only SQL. NoSQL stands for not only SQL. And then we have in-memory and in-database computing. So, so back to data warehouse, characteristic of data warehouse. So this data warehouse is subject oriented, meaning that it is organized based on subject. It is integrated, so we have multiple subjects. We have multiple data storage integrated into one system. So it is time variant, so you can do time series analysis. It is non-volatile, meaning that you cannot change the data, you cannot edit the data, but in order to effect any changes, you will have to post another entry there. It is can be summarized, and then it is not normalized, so you don't really normalize the data, although it is a relational database. And then it is metadata. We include metadata there to describe the data. Yeah, metadata is a data about a particular data. So you can have a web-based data warehouse. So it can be relational and multidimensional. It can be in the several format. It can be client server, real time, and active data warehouse. So besides data warehouse, there is another term we call data mart. Yeah, data mart are smaller data warehouse. Data mart. Yeah, so we have data warehouse, which is the large scale, and then beside this data warehouse, we also have a smaller scale data warehouse that we call them data mart. So this data mart is specific to a unit or a division or a certain function in the organization. Maybe you want to have a marketing data mart. So we have a just small data warehouse that cater for marketing, specific marketing function. So we call them data, we call it data mart. Or finance. Yeah. So we have a small data mart or a data warehouse, a small data warehouse, we call it data mart, just to cater for the finance function. Because when you do data mining, when you do analysis, descriptive, predictive, and then you don't want to process the whole bunch of data in your data warehouse. You extract certain amount and build it into a smaller data warehouse that we term it as data mart. So we can have multiple function. We can have a data mart for marketing. We can have a data mart for special project. A special project meaning that you have a special project that you want to do, and then you don't want it to. You want to have a specific or smaller data warehouse that you can analyze the data, do data mining, and so on. So we develop a smaller data warehouse. We call it data mart. Okay, there are two types of data mart. One we call it independent data mart, and then the other is dependent data mart. The difference between dependent data mart and independent data mart is the relationship or the dependency to the data warehouse. So a dependent data mart is a link or there is a subset of the data warehouse, meaning that all these data that is being fetched to the data mart actually come from the data warehouse. And then the result is being uploaded back to the main data warehouse. So it is dependent on the data coming from the data warehouse and the main data warehouse, and then the result of the also goes back to the main data warehouse. So that is dependent data mart. The other one is independent data mart. It is, for example, like you have a special project, you have a small business unit that is not yet, this is not related, or it's actually you don't intend to combine it with the main data warehouse. So that is an independent data mart. So two types of data mart. We have dependent data mart, and then we have independent data mart. Dependent data mart is dependent to the data warehouse. Independent data mart is excluded from the, is isolated from the data warehouse. Besides that, we also have operational data store when it is interim area for the operational activity. And then you have operational data mart. You have enterprise data warehouse, which is a large data warehouse meant for the operation. And then we have metadata, which is another repository that supports the data in front of the data warehouse, the large data warehouse. So data warehouse is uh, meant for data-driven decision making. So you can, okay, this is the example here. Okay, this is the generic data warehouse framework. You can see this here. We have an enterprise data warehouse here in the middle. Yeah, so this is enterprise data warehouse. We can replicate it to avoid uh, losing the data. And then you can have a metadata that describes this data. And then you have this data mass. So these are all dependent data mass. And independent data mass will be excluded, will be not linked to the enterprise data warehouse. You can have another independent data mass. So where do this data warehouse get their data? From other data sources. It can be from your TPS, transaction processing system, TPS, which is here, online transaction processing, other, and then it can also pass through from the TPS, it can also pass through your ERP, Enterprise Resource Planning System, or POS, point of sale is a TPS as well, point of sale, or a legacy system, or other CRM and so on. And then also can come from your external data. It can also come from the web. And then once you have all this data in your data sources, we can pass it to there is a process called ETL process. ETL stands for extract, transform, and load. They will extract data from these various repositories from various sources, ERP, point of sales, or transaction processing system. This is OLTP, online transaction processing, the external data. You will select this data, you will extract this data. The process will involve will be the selection of this data, and then you will extract this data, but this data will come in various format, various type of data. So you need to transform them into the format that you will use for your analysis. So you'll do transforming of this data, and then you integrate this data, and then you load this data into your data warehouse. Now we have a relational database in your data warehouse. And then this relational database will be supported by a metadata, then you can replicate them. Then this metadata, for certain analysis, you want to do a small scale analysis rather than analyzing the whole data warehouse, you will put them into your data mart. You can have several data mart. This is in a dependent data mart. Yeah. And then you can also have an independent data mart here. It's not shown here. Then you have an API, application programming interface or middleware, so that you can do your analysis. You can develop your dashboard. You can do your online analytical processing. You can have your custom build application. You can do text mining. You can do business reporting, gathering data from this data warehouse. Okay, you can see the whole picture here where data from various sources are being gathered. You have this ETL process, extract, transform, and load process, where you select, extract, transform, integrate, and load this data. You do cleansing of this data. Cleansing of this data is before this ERP, because data will be processed before that, even at OLTP will be pre-processed. Pre-processing of data, we have learned pre-processing of data, that is before they go into these main data sources, before they go to this ERP and so on. So, but once they are in here, so data are being cleansed, and then we will do the selection, extraction, transforming, integrating, and loading the data so into an enterprise data warehouse so that you can uh, analyze them. But before that, you can have either you have a no data mart option where the application, the analytics application can directly analyze data from the data warehouse, or some organization prefer to have a data mart. Yeah, enterprise data warehouse model, EDW model, will have data marts so that the analysis function will be done in a smaller scale based on the subject of the data mart. And then you will have your API and middleware in case of certain application or certain format, certain processing that you need to done, certain translation that you need to done from uh, before you are able to analyze this data. So there could be there are three method of three level of architecture. First, this three-tier architecture. It can be two-tier architecture or can be a one-tier architecture. For the three-tier architecture, you will separate your workstation, application server, and database server, where you have data acquisition software at the back end. We have data warehouse, and then you have click at the front end will be the client. So you can see here where there is a client that put in the data. The client can put in the data directly, key in, or they can also use some sources material to collect this data. But usually this data will also come from ERP, CRM, yeah, SEM method, or like you have. So, and then the system will be passed on to the application server. Yeah, the application server is where the data warehouse and the database server is. Yeah, then you have a database server backend. You can also have a two-tier architecture where the application server and data server is the same server, or a one-tier architecture. One-tier architecture is everything on the same server. Yeah, one-tier architecture. So you look into issues to consider when you decide which architecture you want to use. Will be looking into your DBMS, database management system. Maybe you use Oracle, you use uh, DB2, or you use MySQL, or other format that you use for your database. And then whether you use parallel processing, what kind of, do you have parallel processing or partitioning, and then your data migration tools, and then what tools do you use for your data retrieval analysis. Yeah. So you can also have web-based data warehouse architecture where the data warehouse and application server is at the back end of the web server. So the client using a web browser will access the web server using internet, intranet, or extranet. And then web server, besides delivering the web pages, they can also allow the client to access to the application server and the data warehouse. The application server will be able to analyze the data from the data warehouse. So alternative data warehouse architecture that we have is we have 5 here. So the first step is the independent data mart architecture, where we have this in source system, various source system. You can have your ERP, SEM, CRM, or any other system or web system, or your POS, point of sale systems. And then all this data collecting from this POS, point of sales, and so on, will move to a staging area where you will do this ETL, extract, transform, and load. And then the ETL is a staging area, is a storage space or server that you do your staging. And then it will move into the independent data mart. So they will have many independent data marts. So, and so it is atomic data, or summarized data, and then end user will be able to access the independent data mart to do analysis, meaning that they can get from several data mart to do analysis, or they just look into particular data mart to do their analytics, yeah, to do their descriptive, predictive, or prescriptive analytics. That is independent data mart architecture. The next method is data mart bus architecture with linked dimensional data marts. So same goes, we have source systems. Source system will be in ERP, SEM, or your point of sale system. The same goes, it will pass through a staging area where you do your extract, transform, and load. Extract is you will be extracting data from the source system, and then transform, because data come in various format in the source system. You will transform them into a basic or standard system that you use in your organization, and then load them into your data, dimensionalized data marts, meaning that this data mart are being dimensionalized according to certain dimension that you have determined in your organization. So instead of the first one where we have independent data mart, this dimensional data marts is linked. These are linked data marts. They are small data marts, but they are linked to each other. There is a bus architecture. Bus architecture meaning that when from the ETL, they will pass through a bus. Yeah, bus is like, and then this bus will pass on the data mart, the data to the specific data mart according to dimensions. And then the analysis will be done by the end user. The end user are the business users, which is the managers. You all, when you are business managers when you do your MBA. So you will be able to fetch the data from the data marts based on the dimensions that you are looking for, the types of analysis that you want to use. So this is the second method, which is the data mart bus architecture with dimensional data mart. So this is data mart. Then we move into a proper data warehouse. Then the third method is hub and spoke architecture, which is a corporate information factory. It is an enterprise data warehouse. Enterprise data warehouse, or we call it hub and spoke architecture. We have same thing. We have the source system, your many system, your point of sales, your um, CRM, your many or your other MI system, even though your knowledge KMS, knowledge management systems, and so on, ERP, and so on. Uh, you will collect this data and pass through the staging area where you do your extract, transform, and load. And then once you have extracted this data from the source system, source repository, you will extract them, you will transform them into a format that suitable, that standard, your standard format, and load them into a centralized data warehouse. Load them into a centralized data warehouse where all the data are being normalized in relational database. So it is a normalized relational database warehouse. Yeah, it's actually a large database, that large repository, large repository, and then this large repository will have subset of data mart, dependent data mart. This data mart process some atomic data provide back data to the data warehouse. So the data that uh, come is loaded from the staging area will pass on to the data warehouse first, and then it will be loaded into this dependent data mart. Yeah, so we have many independent data marts. This is what we have here. Yeah, this is a hub spoke model where you have many data marts here. This is the hub and spoke model. Many data marts. So this data come from many data sources. You have this ETL process, move into the data warehouse, and then you load it into the data mart for analysis. Then the business analysis application will be done here. This is number 3, which is the hub and spoke architecture, which is the enterprise data warehouse. So the analysis, same goes here. You can see here, the analysis can be done directly by the application direct to the using the data from data warehouse, or it can go to, you can use the data in the data mart. So same thing here, you can see this. So you can either go analysis can be done using the data, normalized data from the data warehouse or from the data mart. So this is an enterprise data warehouse. This is data mart. The first one, data mart. Second one is data mart with link dimensional data marts. This is independent data mart. The first one is independent data mart. Second is a dimensionalized data mart. Third is the dependent data mart where you have, it is called dependent data mart because the data comes from a data warehouse. The second one, there is no data warehouse, just data marts, but they are dimensionalized data marts. The third one where you have a normalized data mart, normalized warehouse, data warehouse, and then you have dependent data marts. Yeah, remember the second one we have a bus. Actually, it is linked through a bus. Yeah. And then we have centralized data warehouse architecture where there is no data mart. Yeah, number 4, D here, centralized data warehouse architecture, there is no data mart. So from the source data, move into the staging area. So the staging area will load to one single large uh, normalized relational data warehouse. And then analysis will be done all in the centralized data warehouse. So there is no data mart in this case, in number 4. Okay, but you can also have many data warehouse, many data mart, and then many legacy system. We call it federated architecture. The fifth one is federated architecture, meaning that you the source system is actually we mean not the really a source system. Actually, you can imagine all these three A, B, C, meaning you have independent data mart, you have data mart bus architecture, and then you have hub and spoke architecture. You can have centralized data mart. So these are all separate data warehouse, data warehouse or data mart. And then all these data mart and data warehouse, you have they have they have a logical model that map them into a central integrator. So we can be a data mapping based on the metadata, because all these data have a metadata. Using this metadata, you can apply ontology. You can read about it, yeah, ontology or a taxonomy or a schema. So we on the metadata, so you can link this several data based on the dimension, based on the subject. So you can develop a data mapping based on using the metadata. And then you can have integration of this data, and then you can do analysis at the back end. So analysis is done by an integrator here, yeah, that link towards all these other database. This is what we call federated architecture. So each architecture have advantage and disadvantages, and then which architecture is the best? I would say it depends on your situation. Whether you start from a data mart level, and then you link to your data mart, or you can have a hub and spoke model where you have the data warehouse and data mart, or you just have a data warehouse. And then from the data warehouse, centralized data warehouse, also you can move into expand, and then you have move into hub, spoke, and model where you have data marts supporting the data warehouse, or you already have several models. For example, in Malaysia, we have data in our lembaga hasil uh, uh, the tax department, ya, lembaga hasil dalam negeri. We have the other data various repositories. So we have several data warehouse, and then we map them using metadata, and then we have federated architecture. Okay, and then the decision on which factor that you want to select will based on information interdependence between the organizational units. For example, in Malaysia, we have DPF, we have, okay, so we have many units. Whether you want to apply a federated architecture, or you want to do something like PADU, where you integrated everything into a centralized data warehouse, which is in D above, or you can have an C, where we have a hub and spoke model, depends on the information interdependence between the organizational units. And then on the upper management's information need, what do they need in making their decisions? Urgency of need for a data warehouse. If you urgency and need of data warehouse, it's easier to develop the independent data mart architecture first. Yeah. And then, or you can have nature of end user task. The end user would be the analysis, the data analyst, the business analyst that uses this data. And then whether there are constraints on the resources, look into the strategic view of the data warehouse prior to implementation. Compatibility with the existing system. You have this existing system. Maybe it's easier to do data mapping rather than developing a data warehouse where you have to spend a lot of money. And then perceived ability of the in-house staff, whether you have many data analysts that you can use or data data engineers. So you can have many data marts, or you can have just one data warehouse. So you don't have so many in-house staff, some technical issues, and also social and political factors. So these are the 10 decision factors, 10 factors that you can use to potentially affect which model or which architecture you'll be using. Okay, in terms of ETL stands for extract, transform, and load. It is And then data integration is the three major process where data access, data federation, and change capture. And then enterprise application integration is a technology that provide allow system to push data from the source data into a data warehouse or the enterprise information integration so that you can integrate data from various sources, web services, and so on. Yeah. So this is data integration and extraction or the ETL process. ETL process is where you extract data, yeah, from various system into the data warehouse and data mart. ETL issues related to the ETL tool is data transformation tools are expensive, can have long learning curve. So important criteria when select an ETL tools will be the ability to read from and write to unlimited number of data sources and architecture. You will need to look into the issue of legacy data, especially when your earlier system using legacy data. So it's difficult to do transformation of this data or even extraction of this data. And then we look into the automatic capturing and delivery of metadata. So data comes with a metadata. So whether you are able to capture and deliver metadata, and then or whether they conform to open standards. Most of the legacy systems doesn't conform to open standards. So it actually they try to prevent switching, to incur switching costs. So they don't conform to open standards. So when you want to select an ETL tool, you look into whether they conform to open standards. And then interface, whether you have an easy to use interface for the developer and the functional user. So there are two methods of developing a data warehouse. It can be an Inman model or a Kimball model. The Inman model is you begin with an enterprise data warehouse. So you can begin with, this is, okay, look into the Inman model. Inman model is something like this. You start with a centralized data number D, at the D there, centralized data warehouse architecture, where you have source system, you have staging area, we have large data warehouse, and then only you move into create C, where you have dependent data mart. Uh, okay, this is known as the Inman model. Inman model is enterprise data warehouse approach, where you create a large data warehouse first, and then when there come needs to have a data mart, you develop your data mart from the extending from the data warehouse. Kimball model is the level A, the stage A here. Kimball model. Kimball model is the cheapest model where you start with independent data mart. They are not linked to each other. And then you dimensionalize, or you can do dimensionalized data mart, integrate them, link them using a bus data mart. And then you can have you can move into the center, you can move into the data mart, and then you develop a centralized data warehouse. Then you move into C. Yeah, A, B, and C. That is if you move from to D to C, that is the Inman model, or the other one, when you move from A, B, and C, that is the Kimball model. Kimball model starts from data mart approach, bottom up. So you have small data mart first, and then you integrate them. You have a bus, and then you integrate. And then you develop a data warehouse so that you can link them all. So okay, and another one. Okay, this is comparing the demand of the data mart approach and enterprise data warehouse approach. Data mart approach with known as Kimball model is the scope is one subject area because it starts with a data mart. The development time is smaller because you're just developing a data mart instead of the large data warehouse. Relational data warehouse take time to develop actually. And then so development cost is also low to medium. And then it builds data transformation will be from low to medium. Enterprise data warehouse, we will have several subject area because we are like developing a large data warehouse. Will take years to develop. The amount development cost will also be high. Yeah, so okay, you can read through this number of simultaneous users and so on. So you can also have a hosted data warehouse that you put into cloud, for example. So you have minimal investment infrastructure because they are on the cloud. So you can freeze up capacity of your in-house system because these are being shared by cloud service provider, CSP, cloud service provider, frees up some of cash flow. Because you don't have to incur high uh, capex, capital expenditure. Instead, you incur small OPEX, operational expenses. Yeah, we read about capex and OPEX. Yeah, and then you can make powerful solution affordable because it depends on the hosted data warehouse, which is on the cloud, and then enable solution to provide for growth. So you can have better quality equipment and software depends on the CSP, cloud service provider. They have your data warehouse provider. Okay. And then have faster connections on the net. Yeah. So how do you represent data in your data warehouse? It need to be on dimensional modeling. So it based on retrieval, based on the subject. So data warehouse is very subject oriented. So it subject is divided into dimensions and then we have dimensional modeling. So two most common method schema is the star schema and snowflake schema. So the most commonly used is the star schema. Star schema is have a fact table and then connected using different dimension tables. And then you have extension of it, we call it snowflake schema. Yeah. And then so they have uh, the data warehouse will have multi-dimensionality, will be broken into dimensions. So dimensions such as product, salespeople, market segments, and so on. And then the by measures and also by time. So this is comparing the star schema just based on dimensions. And then you can have sub-dimensions of it. For example, from this fact table, you start with the fact tables. And fact table, you have just dimension of product, dimension of geography, people, and time. And then in the snowflake schema for the fact table of sales, you have uh, product can be divided into brand and category. And then store, we can have dimension under the store. Date, we can have the month and quarter. So we have more dimensions for the snowflake schema. So now we compare analysis of data in data warehouse, comparing this OLTP and OLAP. Yeah. OLTP, online transaction processing and online analytical processing. Okay, when we do analytics, most of the time we are looking at OLAP, online analytical processing. But there are also systems that collect data and then do transaction processing. These are called OLTP. So OLTP, example of OLTP are your enterprise resource planning system, your point of sale system, or your CRM. So the goal is to collect, can capture and store data. Whereas the OLAP, OLAP, is online analytical processing. So they will convert this data into information so that they can help to make decision, or you call it decision support. So we can break the data into dimensions. We call it data cubes, drill down, roll up, dice, and then it will be able to request ad hoc reports to conduct statistical analysis, and then we'll be able to develop multimedia applications. So these are comparing the OLTP and OLAP. OLTP is to carry out day-to-day function on most of the time at the operational level, where they capture and store data. For example, point of sales. You go to the counter, they will to do transaction in the supermarket. So the POS, point of sales, is to capture and collect the data. not meant to support decision making, but just to capture data. Data come from the transaction database, routine, periodic. Same goes with your ATM, automatic teller machine, that is also doing OLTP. And then, but at the back end, even your CRM, there will be OLTP and OLTP CRM. So OLTP is just to collect the data, and then OLAP will support decision making to the data source will be coming from a data repository or data warehouse. You can do large processes. And then in terms of the execution speed, the OLTP is faster because they just collect data, whereas the OLAP, they do analysis. OLAP operations include breaking them into subset of multi-dimensional. You can dice them, drill down, roll up, and pivot them. Yeah, so things that you need to avoid when you do implement your data warehouse. I think I'll skip this first. Yeah. Massive data warehouse. When you look into data warehouse, you look into scalability. Amount of data will grow. So how do you expect it to grow? Number of concurrent users. So you look into the scalability of your data, and then you need to have a data warehouse administrator to administrate the data warehouse. And then in terms of the future of data warehouse, you can have future, we will have a web, small social media data and big data. So we look into the use of open source software like Hadoop, like uh, Apache Apache Spark. And then we use SaaS, software as a service, cloud computing, and then the use of data lake. Data lake, what is data lake? Skip infrastructure. Data lake is an unstructured data storage technology meant for big data. Comparing data lake versus data warehouse, data warehouse is a structured and processed data. So it's SQL, the schema on the right, very fast, expensive for large data volume, more agile, less agile, and then it's not new. But whereas data lake is any data, it's like uh, a lake. So you can have dead fish, everything inside. It is no SQL, not only SQL. It is very slow, designed for low cost storage, highly agile, and then it's a new method. So the users of data warehouse will be business professionals. You are business professionals, in this case, because you are doing your MBA. And then the users of data lake will be the data scientists. You are not data scientists. Yeah? This program, this is meant for managers. Okay, today we have covered topic 6. We have covered the topic on uncertainty, handling uncertainty in your prescriptive analytics. And then we have developed, we look into development approaches of your in business intelligence and business analytics system, comparing the traditional approach to these business application releases. And then how do we do cross-organizational development approaches? And then what is data warehouse? Understanding data warehouse, the evolution of the data warehouse, characteristics of the data warehouse, comparing data warehouse and data mart, and then how do you develop your data warehouse? Yeah, so this is a generic data warehouse framework, whether and then the types of tiers, three tier, two tier, and one tier architecture of your data warehouse, and then the alternative architectures where you have independent data mart bus architecture, which is based on the Kimball model of data mart development, or you can have the centralized data warehouse, which is based on Inman model data warehouse, and then you can, from this centralized data warehouse, you can also develop into the hub and spoke architecture. Or the Inman Kimball model can also move from the independent data mart to data mart bus architecture with, and then move into hub and spoke architecture. One thing about enterprise data warehouse based on the Inman model is you build a large data warehouse first, and then when the need comes, you will determine whether you will need a data mart. And then the comparison between independent data mart and the independent data mart. And then some information. Okay, this is Inman model and Kimball model. And then the representation, how do you present data in data warehouse? I only put up two, which is the most common, which are the star schema and snowflake schema based on the dimensional models. Yeah, dimension based on the dimensions of your data. And then comparing the data of in the data warehouse, we have OLTP and OLAP. So difference between OLTP and OLAP, online transaction processing and online analytical processing. Okay, I think the future of data warehouse, we are looking into sourcing of data coming from web, social media, or big data. We'll be using data warehouse, or we'll be using open source open source software. There is a software as a service, cloud computing, data lake. Okay, that is all for today. Uh, any question? We have about 5 minutes. Okay, how is your assignment going?
Prof, regarding the assignment, group assignment, next the week after next week will be the presentation, is it, Prof? Do
Yeah,
we need to show the dashboard or just the presentation slide we do?
and you just need the presentation slide.
Okay, thank you.
But you do a screenshot. You can use screenshot. You screenshot because we might not have time to go through the detail, but you do a screenshot in your slide.
Okay, Prof.
Okay, that I think
How long is the presentation for each group?
each group 20 minutes. Actually
20
15
minutes.
plus 5, 15 plus 5 in case of there is some Q&A. 15 plus 5. You can ask question actually.
Okay.
Yeah. 15 present because you will share and then everybody need to present because it is individual mark. Everybody need to present. So if you have 4 members, 6 members, everybody need to present. You can go up to 20 minutes, and then you have say if it is 4% and 5 minutes each. If it is you can between 15 to 20. So because if you ended at 15 minutes, you can have you can allow for 5 minutes Q&A. After we will do the presentation first on the 23rd, right? On the 21st, on the 21st. We'll do the presentation first. After the presentation, I'll just do uh, a revision, a glance through of a short review of short revision of the topics that you have we have gone through for the course, and then would give some tips on your assessments, what you should look for your assessment. Yeah, final assessment.
Prof,
Okay,
for the assessment, how long do we have? How many days?
2 days. Two
So
days.
what is the format of the assessment like?
There will be I will discuss next week, but it will be section A and section B. Section A, there will be a case study, and then from the case study, there will be questions relating to the case study. And then besides that, there is section B, where there is a general questions on the topic, on the course of the course.
Are there any data analytic required for the assessment, Prof?
Yes, come again?
Do we need to do any data analytic for this assessment?
No.
Okay. No, thanks, Prof.
Okay. But you need to apply, you need to understand how do you apply the analytics. You write up, there will be not so much of analytics, but you need to your answer will be what will you do? But don't mean not doing the analytics, but you plan, you propose how do you do your analytics.
So it will be like case based.
Yes, a case based. And then you tell how will you do your analytics.
Got it. Not Prof. Thanks, Prof.
Okay, now is
It-
9. Yes, any question?
Sorry. Yeah, last one. The quiz. Is there only one question for the quiz?
There is another one actually. Okay, One question for your case, especially one question, just one question. And then please upload in your, I see that most of you upload in the, there is a place actually, upload in the quiz. There is a place that you need to upload. So I can retrieve in your LMS. I'll discuss it next week. Yeah, I will discuss it next week where to upload. Okay.
Thank you.
Okay. That's all. Thank you very much. And then see you not next week, 21st, on the 21st.
Right.
Okay.
Thank you.
Thank you. See you.
So,
And then Assalamualaikum.
Thank you.
Thank you, Dad.